Good morning to everybody. I'm Monica Cardarilli from the European Commission's Joint Research Center, and I work in the unit on technology innovation in security. Thanks for the invitation to this workshop, and where my contribution aims to present the emerging challenges and future perspectives for critical infrastructure protection and resilience, also within the context of current EU efforts in the area of hybrid threats. The GRC research sites are located in several member states whose headquarters is in Brussels. The GRC is the in-house science service of the European Commission, where each site hosts specialist laboratories and unique research facilities, and is home to thousands of scientists working to support EU policies. Infrastructure systems are the backbone of modern economies, and critical infrastructure resilience is essential to the societal well-being, ensuring the day-to-day delivery of social goods and services. So the risk landscape facing critical infrastructures worldwide is very complex and in constant change. And as supply chains, critical infrastructures were not exempted from the consequences of the COVID pandemic. The global escalation of the COVID crisis indeed has forced critical systems into unexplored operational conditions, where the increasing exposure to service disruptions triggered by concurrent natural hazards and especially man-made attacks has revealed how essential critical infrastructure networks are, as well as their interdependency. Human-induced threats related to critical infrastructures have been recognized as potential security risks for a long time. From disruptions to a nuclear power plant to an exposed electrical grid, both public and private sectors hold the responsibility of protecting the society from potential malicious attacks. Among the threat sources, there are, for instance, insider threats carried out by the critical infrastructure personnel who has inside information concerning security practices, data, and computer systems as well. The threat may involve fraud, the theft of confidential information, sabotage of computer systems, who take advantage of their access to inflict harm on a critical infrastructures or organization. Other relevant threats are represented by organized criminal activities and terrorism, interfering in most cases in the provision of cyber-dependent services to extract the payment of a ransom in exchange for service restoration. And finally, most insidious hybrid threats, an emerging hazard which I will describe in the next slides. In today's connected environments, digital and physical systems are converging and creating new security concerns, where attacks on critical infrastructures present novel and sophisticated scenarios that can put entire population at risk, not only affecting the business continuity status of the affected critical infrastructures and its interconnected systems. First of all, recent cases of cyber attacks on critical services such as hospitals have attracted widespread attention, especially during the pandemic time, and similar events sometimes challenge drastically safety, security, and reputation as well of the involved businesses and critical assets. Anyway, threat identification is only one component of the risk assessment process. Effective risk assessment methodologies are the cornerstone of a successful critical infrastructure protection program. Indeed, risk assessment is indispensable in order to identify and assess threats and system vulnerabilities, and to evaluate the impact on assets. The probability of occurrence of identified threats and their impact severity should be assessed under the lens of the whole critical infrastructure architecture, but also including the secondary effects those threats can induce to the civil society, as well as economy and environmental context in which the critical infrastructure is located. There is a significant number of risk assessment methodologies for critical infrastructures, but in general, the approach that is used is rather common and linear, consisting of some main elements: identification and characterization of threats, identification of vulnerabilities, and evaluation of impacts. The main differentiations of those methodology are essentially based on the scope of the methodology, the audience to which it is addressed, and the domain of applicability as well. The second important parameter that has been mentioned by the previous speakers, that is also entering the stage for the risk assessment methodologies of networked infrastructures, is the element of interdependency. Upon the cross-sectoral interdependencies relies the concept of resilience, defined in the context of critical infrastructures as the ability to absorb, adapt to, and or rapidly recover from a potentially disruptive event. Clearly, this stems from the fact that resilience cannot be handled at asset operator level, since it requires the collaboration of various actors and different sectors in many times. In this way, in this new way of thinking, resilience can be viewed as the quality which reduces the vulnerability of an element, absorbs the effects of disruptive events, enhances the element's ability to respond and recover, and facilitates its adaptation to disruptive events based on past experiences. In this respect, we can say that resilience assessment plays an important role in ensuring the security and reliability not only of these elements alone, but also of the system as a whole. Cross-sectoral interdependencies offer also opportunities for a more efficient exploitation of resources and orchestration of services. Yet it might sometimes allow existing vulnerabilities to escalate and new ones to emerge. Under these specific circumstances, even a relatively small malfunction affecting a single component may result in broad-scale and long-lasting impacts, sometimes through cascading effects hard to predict and prevent. An example is the modeling of vulnerability and interoperability of critical infrastructure systems that represents critical infrastructures as network of nodes supplying services to both their neighbors and to end customers. This approach allows for higher flexibility in describing and simulating multi-sectoral interdependent critical infrastructure systems, analyzing complex cascading effects, and assessing also different demand profiles that the system could manifest when facing a critical event. This complexity stresses the need to improve critical infrastructure resilience and to address interdependencies by using appropriate tools to support decisions and policy making. Furthermore, new emerging threats must also be considered when referring to critical infrastructure protection and resilience. The term hybrid threats refers to an action conducted by state or not state actors, whose goal is to undermine or harm a target by influencing its decision-making at the local, regional, state, or institutional level. Such actions are coordinated and synchronized and deliberately target democratic states and institutions' vulnerabilities. Activities can take place in different domains and are conducted using a wide range of means designed to remain below the threshold of detection and attribution. By using unconventional and conventional means, hybrid actors veil their action in vagueness and ambiguity. The use of different intermediaries or proxy actors supports the achievement of these goals. Indeed, hybrid action turns the vulnerabilities of the target into a direct strength for the hybrid actor, which makes hybrid action more difficult to prevent or respond to. The JRC, in cooperation with the hybrid COE, has designed a conceptual framework to increase the understanding of hybrid threats and facilitate the development of effective measures to improve resilience against these threats. In particular, 13 domains have been identified in which an hybrid threat can operate, where each one describes the components of hybrid threats in terms of actors, objectives, and tools, as well as the different phases of action. Hybrid action is characterized by ambiguity, as we said, and in the context of critical infrastructures, it may consist of disturbances or attacks, cyber operations, different forms of criminal activities, use of military means, and warfare, with concrete implication for security policy. It may also take advantage of existing gaps or ongoing emergencies, compromising an already critical situation with an hybrid interference difficult to detect or attribute. Spreading disinformation is among the most frequently used tools in the hybrid toolbox, playing a very impactful role in polarizing public opinion and trust towards both public and private entities, especially when they provide critical services to the civil society. Early detection and situational awareness of critical operators and intelligence authorities can support early response to counter hybrid threats. The need for advanced security devices and digital transformation poses the basis for new capabilities to address physical and cyber threats, but it also leads to new threats landscapes and challenges. Innovative technologies are critical tools for improving critical infrastructure interoperability, addressing business needs, and contributing to the sustainable development as well.